Hello guys, in this video I'm going to show you how to solve path with given sequence problem. So, given a binary tree and a sequence phi, if the sequence is present as a proof a root leaf path in a given tree, right? So let's look at a concrete example to understand our problem. So here is the given binary tree, and here is a sequence. A sequence is just an array of number, right? So our sequence has three numbers inside. Questions is phi if the sequence is present as root to leaf path in the given tree. So we need to find whether or not this sequence present in our tree, right, as a root to leaf path. So how many root to leaf path are there in this binary tree? There are three root to leaf path in total. The first part is 17, 192, and 199. As you can see, the last part here is actually the same as the sequence. Okay, so how can we solve it, right? So the most intuitive idea here is to just try to traverse to all the root to leaf path and just keep checking, right? If the current path is the same as is if the current path includes this sequence, right? So when you're required to traverse all the paths, you should think of depth first search, right? We can use recursions to traverse the tree in depth here. So let's try to run through our problem manually, right? So probably we need to start at the root node here. We go down all the way to the left, right? 7, we go to 7s, right? So probably at each node we need to compare with the corresponding number in the sequence. For example, here for the node 1 is a root node, right? It's the first node in the path. We're not compare with the first node in the sequence, right? So probably here we need to keep track of current node, current index, right? Current index in the sequence. That so that we can compare the current node with the number at with the number in the sequence at current index, right? So for the first node, we're going to compare with index 0, which is the first number in the sequence. If we go to the child of the node 1, which is node 7 here, we need to increment the current index, right? So that current index will be 1, and we will compare 7 with the next corresponding number in the sequence, right? Here's one thing we need to do. Okay, so next point is about the logic of uh, finding if the sequence is present in root to leaf, right? So the perfect case would be this one, this part, right? So as you can see, every node values in this part equal to corresponding number in the sequence. Node 1 equal to 1 here, 9, 9, 9, and 9, right? This would be perfect case. But how about this case? If we here we 1, it equal to 1 here, but if we go left 7, it is not equal to 9. So so if the current node is not equal to the corresponding one in the sequence, node value is different than the corresponding in sequence, which is sequence at current index, right? We can just return false, right? Because keep the second here. Why do we need to return false here? So our requirements is to check if the sequence is present as a root to leaf path in the given tree, right? So so it means if there's at least one there's at least one path that satisfies the requirements, then we can return true for the whole problem, right? So the idea is to check every uh, path, and if there's a node that is not equal to the corresponding number in the sequence, we can return early. So the false here, it just means that the current path is not satisfy the current path does not satisfy the requirement. So there's no way. For example, here for example, we have more child of 7. We have it means we can go more depth here, but you can stop early at 7 because 7 is not equal to 9. So there's no way this part from 1 to 7 will be a valid one, so we can return right here. So if the node value is different than sequence at the current index, return false, right? Okay, here's one thing. So what would be the case when it returns true? It is when we are at the leaf node, right? And the current index is also the last index in the sequence. So if um, current index equal to the last index in the sequence, which is sequence dot length minus one, and we are at the leaf node. Leaf node. Let's subtract it into. Let's say here will equal to last num in sequence, and the leaf node, and this these conditions, but we change it to equal. So if this is true, then the current path is valid. We return true for the path, for the current path, right? And also for the whole problem, because if there's at least one path, one valid path, then we return true for the whole problem. Means we can find a root lead path, right? A valid root lead path. Return true. So okay, I think that can be enough for our problem here. Let's try to get into coding. Okay, so our functions here takes into arguments, root, and sequence. Uh, like we discussed earlier, we need to keep track of the current index, right? So for example, it's for example, if we are at node 1, the index should be 0. And if we go down one level, then we need to increment the current index, right? So I will have a current index values here. Initially is 0, right? If you don't pass anything in. Okay. So for at each node here, these functions wanna call it recursively, right? And each recursive call will wanna visit one node, right? So I will establish a base case for the recursive call. The first thing is that what if the routine node? It means we reach the end of our tree, right? Our path. Here I can return false. I can confidently return false because I'm going to have a check at the last node, right? Going to have a check at the last node. And if it had not returned false for the last node, and it goes to the uh, left or right, it will return false. So if we don't have a root, return false. So here is if the node value, which is root.file is not equal to corresponding value, which is uh, sequence at current index, will return false right away. Okay, actually here we can abstract it out into matching value is if it will be equal is not matching value, then I will return false right away. But if it didn't return here and it comes to the next line, it means we have a matching value of a kernel, right? So let's see, if it comes here, it will be a matching value. So if it is this conclusions, if it's the last num in sequence and it's a leaf node, and we can return true. Actually, we don't need to fill out these conditions because if it comes here, it means this is true, right? Okay, so we need to define what it means to be a last number in sequence. It means our current index is equal to what? Equal to last index in the sequence, second.length minus 1. What it means to be a leaf node when we don't have a root left and we don't have a root right. Here we don't need to check for the root because if it didn't come here, it means here we are for sure we have a root node. Okay, let's check it again. If not return false, if matching values mean this conditions. If it's not matching values, returns early right away, return false here. So if it is last num in sequence and it's a leaf node, it means, for example, we are here, we are at this node, right? It is leaf node. Firstly, it didn't come here. It's a matching value, of course. 9 equal to 9, and it is the last node in. So the current index now is 0, 1, 2. So 2 is the last index here, right? And is a leaf node because node 9 has no left or right. So it means that it means that this is a valid path. So we can return true here, right? So if uh, if it hadn't returned here, if it didn't return here, then it means that we could be at the middle of the way. For example, we are 9, right? So 9 equal to 9. Yeah, so we want to go to the next node. So we want to go down, right? Either left or right. Okay, so I need to go both way, which is left or right. So I will make it a loop to left child and right child, and it will be root dot left and root dot right. Child here will be either left or right. So we only want to go to left or right if we only want to go to left or right if it is not null, of course. If we have a child which is not null, I can call it recursively here. Call a recursive call here, like this. Gonna visit the child, right? Gonna visit the child. No, the second would be the same here. The current index will be current index plus 1. We probably, because our functions here could return, this one could return true or false, right? Depends on which one of these it will match. For example, it could comes here, it comes here, it comes here. General, either true or false, or in another word, whether the current part is valid or not. So I could check here that if we have a child, we'll go this way, and this will return true or false, right? So if this one return true, to be more explicit, this return true, I can return true for the whole problem here, right? And if at the end uh, we finish visiting both left and right, and we haven't returned true here yet, it means both left and right are not valid paths. So at the end, I will return false. Yeah. Okay. I think that is it. Let's run the test. Just 8, 4. Hopefully, no. Okay, it works. Let's double check it a bit. Okay, so that is it for this problem. So thanks for watching and see you in the next video. Goodbye.